Welcome to this session where we are going to do calculus, and the topic we are going to concentrate on is differentiation by quotient rule. These are some of the exam questions which have been asked for the past years. Use the quotient rule to find dy over dx for the given that equation, and that also y is equal to tan x, y is equal to sec x, y is equal to sin 2x over x plus 3. Let's start with the first question. How can we use the quotient rule in differentiating or finding the derivative of a certain equation or function which have been given? The first thing we're going to do in this session is to discuss the quotient rule, the formula itself. So let's look at the formula itself. So let's say we've been given a certain function f of x, which is given in a form, let's say u over v. You can see that there is a division, u divided by v. So what we are going to do in this, function, you are going to use the formula. So when you are using the formula, we say derivative of the function x will be equal to, so you start with v, then you differentiate the function, the numerator of the function, so you say v u prime, then you subtract. This time around you are going to consider u and differentiate v divided by v square. So this is the formula for quotient. So this is the quotient. This is the quotient rule. So let's look at how we can apply this quotient rule in solving those exam questions. So the first question is y is equal to 4x plus 1 divided by x minus 3. So we have y is equal to 4x minus 1 divided by x minus 3. Okay, 4x plus 1 divided by x minus 3. 4x should be a plus there. So how can we differentiate? So we're going to say our top function will let it to be, our top numerator, our numerator will let it to be u, then our denominator will let it to be, this will be our u, the denominator will be our v. So now we use the formula dy over dx is equal to v u prime minus u v prime over v square. So we've seen our u is there, the numerator. So our u prime, now we are differentiating 4x plus 1. So the derivative of 4x is just a 4. The derivative of a constant 1 is a 0, so even if we don't write it, then we differentiate our v, the function v. So the derivative of x is just a 1. the derivative of negative 3 is just 0, the constant. Then we are going to substitute these values in this equation. So this will be equal to v, our v, the function is x minus 3, then multiplied by our u prime. Our u prime we found is 4 there, then minus our u is the top value, which is the numerator x 4x plus 1, then our v prime is just a 1, then over v squared, meaning x minus 3, then we square it. So I can get rid of this. So I'm going to say dy over dx will be equal to, this 4 is multiplying by everything in the parentheses. So I'm going to say 4 multiplied by x, that is 4x. 4 multiplied by negative 3, that is negative 12. We come this side, 1 multiplied by 4x plus 1 is just 4x plus 1. So I'm going to distribute this negative to follow this function. So I'm going to say negative multiplied by 4x, that is just negative 4x. Then negative multiplied by 1, that is just negative 1. Then everything is over x minus 3 square. So we can now simplify this to, so you can see that 4x and 4x can cancel out because 4x minus 4x is 0. So negative 12 is what we remain with. Negative 12 minus 1 there on the numerator. Then on the denominator we remain with x minus 3 square. So I can get rid of this. So what are we going to have? So our dy over dx will now be equal to negative 12 minus 1, that is just negative 13, over the denominator is x minus 3 square. So this is how you can differentiate the first one. Let's go to the next one, which is y is equal to 10x. Okay, so our second question is y is equal to 10x. So y is equal to 10x. But we can change this 10x into a fraction. So I'm going to say 10x is equal to sin x over cos x. Then you let sin x to be u, then cos x to be v. At this point now, we find our u prime. Our u prime, that is the derivative of sin x, which is just a cos x. Then v prime, the derivative of cos x. So v prime, derivative of cos x is equal to negative sin x. Then we substitute in the formula, dy over dx is equal to v u prime minus u v prime over v square. So this will be equal to, our v in that case is cos x, then it is being multiplied by u prime. Our u prime is also cos x, then minus u, our u is sin x, let me get rid of this. Our v prime, it's negative sin x, so it's negative sin x. Our v prime is negative sin x over, remember we had v was cos x, so v squared, so we're going to say over cos x square. So I can get rid of this. So what is our dy over dx? So this will be equal to cos multiplied by cos x multiplied by cos x, that is cos square x. Then negative multiplied by negative, that is a positive, so it will be plus sin x multiplied by sin x, which is sin square x. On the denominator, cos x square, cos square x rather. So we can now simplify this. Cos square x plus sin square x, from our identities we said this is just a 1. We did trigonometry and we said cos x square plus sin x square is just 1. So I'm just going to say 1 over cos square x. But you see, when you have 1 over cos square x, that is just a sec square x. So meaning that the derivative of tan x is just sec square x. So that we found the answer. Let's move on to the third question. Y is equal to sec x. Find y over dx. Okay. So our next question we have is y is equal to sec x. So sec x can also be written as 1 over cos x. Then we are going to let 1 to be u, cos x to be v. Then you can use the formula now. Dy over dx is equal to v u prime minus u v prime over v square. So this will be equal to, our v is cos x, our u prime. Okay, so you can find the u prime, the derivative of 1 is just a 0. That is a constant, that's the derivative of constant. Then v prime, the derivative of cos x is just negative sin x. Okay, if you're not sure about how the derivative of trig functions are coming about, like the derivative of cos x and the derivative of sin x, you can check out this on our channel. So what is our u prime? It is just 0. Then minus the u is 1 multiplied by, what is our u prime, v prime? Our v prime is negative sin x over v square. V is cos x, so it will be cos x then square. So let's now find dy over dx. So what is cos x multiplied by 0? It's just 0. Negative 1 multiplied by sin x, that is positive sin x, over cos square x. Okay, at this point we can just simplify this to be sin x. Since we have cos square x, I'll expand this. I'll say cos x then multiplied by 1 over cos x. I haven't changed anything because 1 times sin x will still give us sin x. Cos x multiplied by cos x will still get us back to cos square x. So this will be equal to, now we know that sin x over cos x is tan x from our trig identities. So check out the trig identities on our channel and know how this is coming about. Then 1 over cos x is just sec x. So that is our dy over dx. So this is how we can find the derivative of sec x. Then what is the derivative or dy over dx of sine 2x over x plus 3? Okay, so this is our last question. So we have y to be sine 2x over x plus 3. Let's hope it's x plus 3, yes. So we are told to find the derivative. What is the derivative? So we're going to let this to be our u as usual, this to be our v. Then we find u prime, which is the derivative of sine 2x. When you're finding the derivative of sine 2x, we first have to differentiate 2x. So that is just a 2. Then what is the derivative of sine x? Okay, so the derivative of sine x, we know it is cos x. So now, because where there is x, there is 2x, we say now cos 2x. Okay, then we go back to v. What is the derivative of x? Is just 1. Derivative of constant is just a 0, so no need to write it. Then we write the formula dy over dx is equal to v u prime minus u v prime over v square. So this will be equal to what is our v? Our v is x plus 3. What is our u prime? Our u prime is 2 cos 2x. Then minus, what is our u? Our u is sine 2x. What is our v prime? Our v prime is 1. Then everything divided by v square. What is our v? Which is x plus 3. Then square. You can get rid of the top part there. So let's now try to simplify this. So we say dy over dx will be equal to, so this we have is x plus 3, then multiplied by 2 cos 2x minus sine 2x multiplied by 1 is just sine 2x over x plus 3 then square. Right. So for this question, you can even hint here, this is the answer. Unless you start simplifying this further, but in an exam that won't add any extra mark, because if you start simplifying sine 2x, you write it as 2 sine x cos x. Then you also expand cos 2x. That won't add any extra mark unless you've been taught to simplify it as far as possible. But for this level, we can end here as our derivative. If you found this to be helpful, don't forget to like, share, comment, and also subscribe to the channel. Thank you for watching.